Okay guys, so we're focused on our Utah Middle School Math. We're on lesson 1.1H. We are getting ready to tackle a little bit more challenging word problems. And again, we're going to start by putting these types of word problems together from mathematical expressions and equations to help understand how people write word problems, in hopes that knowing how they're put together will help us to solve them better. So let's look at some cases. We have an example we went over in class where we're talking about birthday parties. We are given an expression for the number of friends, an expression for the cost at Boondocks, an expression for this place at Raging Waters, and then we're told 8f plus 60 equals 20f. So let's start writing this word problem. I'm just going to focus on that first part, the number of friends. So I'm just going to pick a name at random. Bob, good old Bob, is throwing a birthday party and plans to invite F number of friends. That's what it would probably look like in a word problem that you might read. Let's look at the next couple expressions. First, it seems that he has two choices, Boondocks or Raging Waters. So you can do it at Boondocks or at Raging Waters. Boondocks charges $60, and that's what this plus 60 is. They're charging a fee of $60, and then this 8f is basically saying every friend costs $8, because if f is one friend, 1 times 8 is 8. If he has two friends, 2 times 8 is 16. For every friend, we're adding another 8, so that's like a $8 per friend charge. So it's pretty cheap, $8 for each person, but you do have to pay a flat rate of 60. Raging Waters just charges $20 per friend with no other fees, just $20 per friend. Now let's look at this equation part. 8f plus 60. I don't see this as an 8f plus 60. I've seen that before right here for cost of a party at Boondocks. So I don't see 8f plus 60. I'm saying the cost of Boondocks right here. That's what this means, the cost of Boondocks. And 20f, actually to me and mathematicians, are looking like the cost of Raging Waters. So what I see here is the cost of Boondocks equals or is the same as the cost at Raging Waters. Well, that doesn't have to be the case, so I'm going to use a hypothetical to end my word problem. If it turns out that both Raging Waters and Boondocks end up costing the same amount, how many friends is Bob inviting? They don't have to cost the same amount, because if we charge for only, let's say that our f value is just a 1, let's say we have one friend, then 8 times 1 is 8, and plus 60 would mean we have a total value of 68. If f is 1, then 1 times 20 is 20. So if I'm only bringing one friend, Raging Waters is a lot cheaper, $20 versus $68. But the equation says they have to be equal, so we're going to make a hypothetical. If it turns out they both are costing the same amount, how many friends is Bob inviting? And that gives us a problem, and we would solve it. And that's what you're going to look for in your word problems. Conditionals, where maybe things are the same or equal or have the same amount. That means we're going to take some things and put them equal to each other. So in this case, we would then solve it by, we don't have to distribute, we don't have to collect like terms, we do have two variables and one on each side, so I have to get the variables on one side. We could subtract 20, but I like to work with positive variable terms, which means I'm going to subtract 8 from both sides. So 60 equals 12f. Then we're going to divide by 12 to both sides to make our coefficient to 1. 12 divided by 12 is 1, and 1 times f is f. And so what we do to one side, we do to the other, and 60 divided by 12 is 5. And it's a word problem, so we have to put it in a complete sentence. There are 5 friends being invited. If you're going to have the same cost at each place, you must have been inviting 5 friends. Let's look at a couple more. Here's this number trick. So I see that we start with the number n. So Lily and Callie are both given a number n to start with, and then it's a trick, so I'm assuming they might be asked to change because I noticed that each one is going to change n. So then I'm going to move on to Lily. And I have to remember the order of operations. And the order of operations are, please excuse my dear Aunt Sally, which means we start with parentheses. Since there are parentheses with Lily's number, that has to be done first. So before I can say anything about multiplying by 3, I have to start with parentheses because that's how order of operations work. So we have to start by saying Lily first adds 5 to it, n plus 5. She added 5 to her number. It's in parentheses. That's why I know it has to be done first. Then she multiplies by the sum by 3, because when we add things, that's a sum. So she first adds 5 to it, takes that number, and multiplies it by 3. The next then is Callie, and it looks like Callie just subtracts 5 from it, the number minus 5. So subtracts 5 from it. Now we're on the equation part. Their numbers don't have to be the same, but the equation tells me that they do end up being the same, or what would happen if they do. So I'm going to use another hypothetical. If Lily and Callie's final numbers were the same, which means they are equal to each other, which is what the equation I've been given says, what number were they given to start with? What is the n, the number they were given to start with? And that was how I'll finish my word problem. So then we would just solve it. We have to start with distributing. So we have 3 times n, which is 3n, and 3 times positive 5, which is positive 15. We don't have to collect like terms on either side, so we'll get the variable on one side. So I don't have to subtract a 1n. I could subtract a 3n, but I want to work with a positive variable, and 3 minus 1 gives me a positive 2. So that's why I'm subtracting by the single n. So then we get our constant to 0 by subtracting 15 to both sides, and we get our coefficient into a 1 by dividing by 2, which gives us a starting number of negative 10. If you start with negative 10, then whatever Lily does and whatever Callie does, we'll end up getting them the same number. Let's look at one last one that we went through in class today. Savings. However many weeks you're saving will be a W. And we see that Sophie's money is 300 minus 40W. Raphael's money is 180 plus 20W. And then we have the equation of Sophie's money being the same as or equal to Raphael's money. So, I'm going to skip this number of weeks. I'll include that in the first statement. I'll start with Sophie. Sophie starts with 300 in her savings. We're talking about savings, so I'm assuming that's 300 in her savings. She's losing, subtracting, so I'm going to write, but then each week she spends, because we're subtracting, so spends $40. And that's where I'll include the W for the week. Then each week, which is a W, she spends $40. So in 1 week, 1 times 40 is 40. 2 weeks would be 2 times 40, so 80. So the next sentence will be, Raphael starts with $180 in his savings account, and then adds, and we would say that. We would say he adds $20 each week, right? 20 per week, 20 times W, 20 each week. And I'll use another hypothetical. Most of these kinds of questions will end with hypotheticals. Or something like this. After how many weeks will they have the same amount in their savings? So yeah, this one doesn't end with a hypothetical. I guess I could say if they have the same amount of money in their savings, what would be, how many weeks will that have passed? But we're going to say after how many weeks will they have the same amount in their savings? Because that's what it's saying. It is saying right here that we have Sophie's money. So here it is, Sophie's money. And we also have Raphael's money. And here it is, Raphael's money. And we're saying that they are equal, so the same amount. So we solve it by getting our variable on the same side, so we're going to add 40W to both sides. We will then subtract 180 to get our constant away, and then we will divide both sides by 60 because on this side I want to make my 60 into a 1, so I'm going to divide by 60. 60 over 60 makes 1, and 1 times W gives me a W. And it turns out that the number of weeks is 2, so they have the same amount of money in the savings after just 2 weeks. So there are some examples for writing word problems based on expressions and a given equation. Good luck on the homework or just practicing the skill in general.